Those are trends, right? But those are very, very important trends, and we need to react, because now we came to a point that our planet is not anymore a sustainable system because of global warming, and this global warming is caused by carbon emission. So if you look now at the trends to tackle this, we have decarbonization, where trend is the growing share of renewable energies, increasing electrification and sector coupling, improving energy efficiency. If you look at decentralization, so we will flexibilization of the energy market is a trend, from customer to prosumer and new market players. And now, how digital? I will present how digitalization will help in connecting the systems and automated process, smart data as a basis for decision making, and new business models that are coming from digitalization. So now, like as I said, why we are here? We are here because climate change has significant impact on our environment, so on our planet, and global leaders recognized and they raised, so concerns were raised. So now, like this global political agenda is moved globally towards decarbonization. So in December 2015, global leaders gathered, and they came to like output from this general output from this Paris Agreement is holding the increase of global average temperature to well below 2 degrees above pre-industrial levels, and pursuing efforts to limit the temperature increase to 1.5 degrees above pre-industrial levels. So pre-industrial levels. So this is industrial revolution. This is the point when our civilization started to consume more fossil fuel in order to support industrial growth. So an industrial revolution happened in 1760, and it started in UK, and it is the period from 1760 until 1840. So before this period, our planet was a sustainable system. So we had carbon in our atmosphere, and carbon was there, and carbon is required, so plants are using carbon for photosynthesis. But our system was sustainable. So what it means? It means that like whatever was emission on that level, our planet was capable and had capacity to absorb it. So, and then humans, so we started to emit more carbon than comparing to capacity of our planet to absorb it by burning fossil fuels. And now, it is in this, let's say 200 years, let's say a little bit more, now carbon emission per year is 8 gigatons, so 8 billion tons above this sustainable level. So it means this is now our baseline, and this is our problem. This problem, why it is a problem? This problem is there because, and this problem actually, our problem is not carbon, because our problem is global warming that is caused by carbon, increased carbon emission and the effect of greenhouse effect. So now, if you look at our sustainable system before 1740, so carbon was in air, and our planet had a capacity to absorb it. So it means that now, if you look now at the first law of energy conservation, so it means so energy of isolated system is constant. So as our planet, it means that our energy would be constant. But there is the sun. Sun gives some, emits some energy to our planet. So there are three ways to transfer the heat: conduction, convection, and radiation. Because there are no molecules in space, so radiation is the only way how this heat is transferred to our planet. And this heat is transferred to full spectrum of light, through visible spectrum of light, infrared and ultraviolet. So it means that during the day our planet was absorbing the energy from sun, but on the other side, that is where we have a night, then this basically energy was then emitted to space. But so system was, energy level was constant and the system was sustainable. And now what happened? When we started to emit more carbon, we started to emit more carbon, but at the same time we started to cut the forest, so we reduced our and pollution actually reduced the capacity of our planet to absorb this CO2. So when this and as I said, thermal energy can be transferred through radiation, through full spectrum. So sunlight will come to Earth, and then it will start to heat the surface. But this ultra red spectrum of light is actually, it will be bounced back to Earth, because as for the ultraviolet light that doesn't go through glass, and the same effect is with carbon. So it is bounced back for atmosphere and it will come back to Earth. So now it means that if we are now increasing this glass, let's say thickness, or if we are increasing this effect, it means that more, so our planet is not capable anymore to reject the heat that is coming from sun. So that's why our system basically is not sustainable. So this creates global warming, this creates temperature increase, this creates a melting of ice that will affect the raising of the sea levels. So this huge problem was recognized, and this Paris Agreement was there to prepare a strategy how to fight with this problem. As well, we have sustainable development goals by UN. So as a very important, energy efficiency is an important part of sustainable development goals that were published in 2015, and they replaced actually millennial goals. And as well, so environmental and performance index is very important for Oman 2040 vision, and one of the important indicators. So now this there are now different initiatives, so I will just go quickly through this. So now, because there is a problem, carbon emission is a problem, and those now 8 gigatons of carbon that we are emitting every year, we need to reduce it. We need to go back to those sustainable levels before industrial revolution. So one of the initiatives is carbon pricing initiatives, and it is growing worldwide. So basically, countries are implementing carbon pricing initiatives in form of carbon tax. And if you look now at ESG factors, so in financial sectors, so environmental, social, governance factors will be important for performance of the companies, and this will be a key factor for making decisions for investments, and this will become a standard in 5 years. So now, yes, okay, sorry, I can skip from this. So now we came to point of decarbonization. So as the first step in decarbonization is to reduce energy consumption. So now my team and my colleagues, we are developing solutions for reducing of energy consumption for buildings and for industrial sector. This part will be more detail explained in the second how we are doing this. But for example, now we need to reduce energy consumption and we need clean energy. So we need renewable energy. So for example, if you look at the building, like typical residential building, and we want to be carbon neutral. So it means that whatever is consumed by this building has to be produced by renewable energy source. So in this case, we can look at solar. So if our peak consumption for this building is, for example, 5,000 kilowatts, so it means that our capacity of the solar panels should be sized based on the requirements for the building. So it means if our building consumes 3 million kilowatt hours per year, our solar panels should produce 3 million kilowatt hours per year in order to be carbon neutral. So it means that we need bigger capacity. So why not first we can reduce energy demand? So we can reduce our energy consumption to the levels where investment for renewable will be lower. And as per our experience, we can achieve, and in most of the cases, minimum 10% of savings. But this number goes around 20 in general, in some cases even more than 30% of total energy consumptions. So it means if you reduce this energy by 30%, investment for solar panels will be 30% lower. And now, how to calculate this carbon emission? So there is a carbon emission calculated from energy consumption, but as well for manufacturing, for transporting, for installing of the solar panels, this as well requires certain amount of energy, and there is a carbon emission due to this process of production and installation, commissioning of solar panels. So today I will focus on energy efficiency and how we can reduce our consumption for buildings and for industrial sector. So now, as well, let's go back to Paris Agreement. So we have sustainability.